Okay, we're going to do another centroid problem so that you can get a better example of me writing one out, and hopefully you will be able to follow and be able to do this on your own. All right, we need to find the centroid of this particular shape. We can do it a couple of ways. One way is to simply divide it right there, and then we have a triangle for our first shape and our rectangle for our second shape. The other way, if you wanted to use the subtractive method, is to make this whole big square shape 1, and then this rectangle shape 2, and then this bottom triangle shape 3, and you would subtract out the areas for shape 2 and 3. But that has 3 steps, that has 3 shapes we have to deal with, and this one only has 2. So let's pick this way. This will be easier for us. All right, and to find the centroid, we have to find the x coordinate and the y coordinate of the centroid for this overall shape. So we're going to start with the x coordinate, which to start, we have to define our reference axis. So I always pick so that my shape falls in the first quadrant. So bottom left is always my 0, 0. You don't have to, you can pick it anywhere, but that's just what I tend to do. So in our shapes, again, we're going to label, I'll draw our line, our triangle is our shape 1, our rectangle is our shape 2. Okay, and then we basically have to fill out the information for this table because that's what goes in this equation. Remember, this is the sum of the x displacement times the area of all the shapes divided by the sum of the areas of all the shapes. So shape 1 is our triangle. So the first thing we have to find is our area. And remember, the area of a triangle is 1/2 base times height. And in our triangle, our base is up here. Okay, so our base is kind of flipped upside down. So our base is 12 and our height is 6. So 1/2 base times height, so 1/2 12 times 6 is going to give us 36 inches squared. So I can go ahead and write that in the table. And then I need the x coordinate of the centroid of the triangle. Well, remember, the centroid of the triangle is 1/3 the base or 1/3 the height. Well, our x direction is left to right. So it's this direction. Well, our centroid from this triangle actually is going to sit right there. It's going to sit closer to our 90-degree angle because that's where the most of the weight or the area of the triangle is. So it's going to sit a little closer. So we need the distance from here to there. So that's 1/3 times the base. Well, our base was 12. So 1/3 times 12 will give us 4 inches. So it is 4 inches from our reference axis to the centroid of that shape. So this is 4 inches. And then if we go look at shape 2, which is our rectangle, we find the area of our shape 2, which is length times width. And it doesn't really matter which way you call it, but we can call this our length and this our width. So our area is 3 times 6, which is 18. So we can put that in our table. And then our centroid for this is going to sit, for the rectangle, is going to sit in the middle of the rectangle. So the x coordinate of that centroid is 1/2 times, and we'll do it times our width since that's the way we label our length and our width. So we need the distance here. Well, 1/2 of 6 is 3. But I can't put 3 in this table because this table is the x displacement or the x distance to the reference axis. That is all the way over here to our red axis. So we need the distance from our centroid all the way to this axis. That's the distance we need. Okay, we need this distance. So we know that this little piece from the edge of the rectangle is 3, and then we know that this from the edge of the rectangle to the reference is 6. So we are going to have to add 6, and that gives us 9 for our x displacement in our table. Now we have to multiply. So 36 times 4 is 144. And that will be inches cubed. And 18 times 9 is 162 inches cubed. We don't have a third shape because we only identified 2, so we don't need that line. And now we need to add up because that's what we need on the top and the bottom of this equation. So if we add 36 plus 18, we get 54 inches squared. So that's the sum of our areas, by the way. And then if I add 144 plus 162, I get 306 inches cubed, and that's the top. So now all we have left to do is to divide. So 306 inches cubed divided by 54 inches squared. Our inches squared will go away and we'll be left in inches. So 306 divided by 54 gives us 5.67 inches. So that's the x coordinate of our centroid for the whole shape. All right, now let's go look and do the y coordinate. So again, our areas will be exactly the same because our shapes are the same. Our shape is still the triangle and it's still the rectangle. So our areas were 36 and 18 and our sum was 54. So I'm just going to go ahead and write those in. 36, 18, and then our sum was 54 and we don't have a shape 3. All right, so we need to find the y value of the centroid for the triangle. Remember, it sits about right here. So the y value is going to be 1/3 times the height. Well, the height of our triangle is 6, so it's 1/3 of 6, which is 2. But that 2 is from the bottom of the base of the triangle. The base of the triangle is up here. So that's our 2 value. But we don't need to put that in the thing. We need to put the y value to our reference axis. So I'm drawing in my reference axis. So we need the y value from the centroid to the axis in the up and down direction because that's our y coordinate, up and down. So if this is 2, then this must be 4 because the whole thing is 6. So 4 is what gets put into our table. Then if we go look at our rectangle, we still get the y coordinate of our centroid. It's still 1/2 times the, what did we call this? I think we called this the length and this the width. So it'll be 1/2 of our length, which is 1/2 of 3, which is 1.5. Well, it's 1.5, but that's from the base of the shape. So from here to here is 1.5. That's not what I need though. I need it from the top all the way, not the top, but the centroid all the way to the reference axis. So I'm going to have to add 6 inches to this to get 7.5 inches. That's what goes in my table. How far in the y direction from the reference axis? Okay, now I'm ready to multiply. So 36 times 4 again is 144. And 18 times 7.5 is 135. And then I need to add those together. So 135 plus 144 is 279. And now I need to divide. So 279 inches cubed divided by 54 inches squared will give me 5.167 inches. Okay, so there's my y coordinate, and this was my x coordinate. So how do I report my answer? Well, when you report your answer for your centroid, it is a coordinate pair, just like math class. So our x value was 5.67, and our y value was 5.167. And then we also have to show it on our diagram or on our shape. So I realize this is not drawn to scale, but we'll have to deal with it. Let's say the point right here, that's our 6, right? So if we need to go over 5.67 in the x direction, I don't know, maybe somewhere right there is 5.67. And then here's our 6 in the y direction. So we need to go up 5.16. So maybe, I don't know, I'm guessing, maybe about right there. And then wherever those two things intersect, that's where our centroid is. And then you can draw your centroid symbol and mark that on the shape. Okay, and then that's all you have to do. All right, work on the worksheet. If you have any questions, let me know. Thanks.